Hi guys, this is Fishers Academy, East Tambaram, Chennai, and today we are helping you guys with a data science course. Yes, first the basic of data science is always statistics, and we are here for you guys and uploading statistics data and basic of statistics.
Good evening, dear friends. We are from Fishers Statistical Academy, Chennai. There are lots of statistical course, online course, and data science course is available. But this is prepared by a statistician who is a scientist and having the background of PhD from Loyola College. So definitely it will be useful with lot of medical applications for the data scientists, those who doesn't know statistics, those who knows the statistics. Definitely it will be a enjoying fun, and also you will learn lot of in-depth statistics. It will definitely useful for your data science activities and big data analysis by R, SAS and other softwares. First I will talk about basics of statistics. It is easy to lie with statistics, but it is hard to tell the truth without statistics. Andrej Drunkus, he told. Next slide. These are the different topics I want to cover in this. First, introduction, then types of statistics, then definitions, then variables and types, then variable scales and description of data, distribution of sample and population, measures of center, dispersion and shape, properties of normal distribution, testing hypothesis, types of error, estimation of sample size, various tests to be used, central limit theorem, parametric tests, t-test, ANOVA, post hoc correlation and regression, non-parametric tests, and tests for categorical data. Summary of tests to be used, qualitative versus quantitative data research, and qualitative research, and software packages that are available. Next slide. Statistics consists of a body of methods for collecting and analyzing data. It provides methods for design, planning and carrying out research studies. Description, summarizing and exploring data. Inference, making predictions and generalizing about phenomena represented by data. Types of statistics. There are two types of statistics. One is descriptive statistics, another is inferential statistics. The first one, descriptive statistics, consists of methods for organizing and summarizing informations, which includes lot of graphs, charts, tables, calculation of average, percentiles. And inferential statistics, it consists of methods for drawing and measuring the reliability of conclusions about population based on information obtained. Includes point estimation, interval estimation, hypothesis testing. Both are interrelated. Necessary to use methods of descriptive statistics to organize and summarize the information obtained before methods of inferential statistics can be used. Next, population and sample. What is population? It is the collection of all individuals or items under consideration in a statistical study. Sample, it is the part of the population from which information is collected. Suppose, for example, I want to find out a university and their course details and other thing, and also find out one survey. For that I cannot take all the University of India. That is our population. For that sample, we will collect 3 to 4 University of Tamil Nadu using simple random sampling methods. Population always represents the target of an investigation. We learn about population by sampling from the collection. Parameters used to summarize the features of the population under investigation. Statistic, it describes a characteristics of the sample which can then be used to make the inference about unknown parameters. Variables and types. Variable, a characteristics that varies from one person to or thing to another person. And types, qualitative, quantitative, discrete, continuous, dependent, independent. Qualitative data, the variable which yield on non-numerical data. Example, sex, either male or female or transgender, like that. And marital status, married, widow, like that. Unmarried. And eye color, there are difference of color. And quantitative data, example, height, weight, number of siblings, the variables that yield numerical data. Number of siblings also numerical data. Next is discrete variable. The variable has only a countable number of distinct possible values. Example, number of car accidents, number of children. Then continuous variables. The variable has divisible unit. Example, weight, length, temperature. Then independent variable. Variable is not dependent on other variable. That is called age, sex. Then dependent variable depends on the independent variable. Example, weight of a newborn or stress, postnatal stress of a woman. So everything is depending on the independent variable. Variable scales. Variables can also described according to the scale on which they are defined. The nominal scale, the categories are merely names. They do not have a natural order. Example, male, female, yes, no. Suppose if you are having diabetic, means yes, no diabetic means no. This is called nominal scale. In ordinary scale, the categories can be put in order, but the difference between the two may not be same as other two. Suppose I am having a disease, I want to know if it is mild, moderate, severe. There are three categories. Then automatically it is having order, because severe is having chronic disease, it is a severe in nature. Mild is somewhat, it is very close to normal, that means better than normal, then it is a starting stage of the disease. So moderate is the middle stage of the disease. Automatically it is in order, so it is called ordinal scale and interval scale. The differences between variables are comparable. The variables does not have absolute zero. Example, temperature, time. Ratio scale. The variable has absolute zero as well as difference between variables are comparable. Example, stress using PSS, insomnia using ISI. It is a ratio scale. And nominal and ordinal scales are used to describe qualitative data. Interval ratio scales are used to describe quantitative data. Describing data. Qualitative data, example, frequency, number of observations falling into particular class category of the qualitative variable. Frequency distribution, table listing all classes and their frequencies. Graphical representation, pie chart, bar graph. Nominal data best displayed by pie chart. Ordinal data best displayed by bar graph. Quantitative data can be presented by a frequency distribution. If the discrete variable has a lot of different values, or if the data is a continuous variable, then data can be grouped into classes categories. Class interval covers the range between maximum and minimum values. Class limits endpoints of a class interval. Class of frequency, number of observations in the data that belong to each class interval. Usually